Okay. So today we will be discussing about dielectric substance and how these substances shows electrical properties when it comes under the influence of external electric field. Okay. Now, till now, we have observed or we have seen, three different types of substances. One type of substance is conductor. Another type of substance is insulator, and our third category is semiconductor. Okay. In case of conductor, okay, let's say that you are having any atom, this is the nucleus, and let's say that this is my valence orbit, outermost orbit, and let's say that you are having an electron there in this outermost orbit. Now, in case of conductor, this electron is not that strongly bound to the atom, that is to the nucleus. You know, it is very loosely bound to the nucleus, because of which, when this conductor experiences a certain electric field, then what happens? It comes out from the atom and it becomes free, and it moves through the circuit if you connect it to any particular circuit there. All right. So that is why we see a very high conductivity value in case of conductor. But in case of insulator, the electrons which we see, they are not loosely bound to the atom. They are in fact very strongly bound to the nucleus, that is to the atom. Because of which, no matter how strong you provide the electric field, how much stronger the electric field you provide, it does not comes out from the atom, it does not becomes free, and hence the conductivity value is zero for insulator. Okay. But in case of dielectric substances, we see little movement of electron inside the atom when it experiences an electric field. Okay, so this is a very important characteristic shown by these dielectric substances. Okay, dielectric substances are nothing but insulators only. Alright, so that means there will be no flow of electrons in case of dielectric. Here also we are not seeing any flow of electrons. That the way we see it in conductors, electrons are moving from one point to another. But in case of insulator or dielectric substances, there is no movement of electrons from one point to another, but there is a little displacement of electrons in case of dielectric substances, little movement or small displacement of electrons inside the atom only. They don't come out from the atom, but inside the atom they show little movement. And when you see such movement, when that dielectric substances, it is coming under an electric field, an external electric field, right? And because of which it shows certain electrical properties, right? We will be studying all those electrical properties, and that is why these dielectric substances are very much implemented in building electronic devices. Okay, because it shows electrical properties when it comes under an electric field. And how does it show electrical properties? Electrons show small movement. Right? So that is why we sometimes call this type of insulators a special type of insulator. Okay? And what are those electrical properties? We'll be studying it today. So basically, dielectric substances is of two types. One is polar dielectric substance, another is non-polar dielectric substances. When we talk about polar dielectric substances, let's say that uh, hydrochloric acid. Now this is a polar dielectric substance. Ammonia. This is again a polar dielectric substance. Carbon monoxide. This is again a polar dielectric substance. And when we talk about non-polar dielectric substances, so we have H2, N2, and O2. These are just few examples of non-polar dielectric substances. So as you can see here, these are the two types of dielectric: polar, which you see here on this side, and on the other side you see non-polar substances, right? So here, what we have observed, that means the center of mass of positive and negative charge coincides, right? Because of which you don't have any dipole moment, right? So when there is no external electric field, so you have, it is clearly mentioned, when there is no external electric field, when this dielectric substance is given not any electric field there, so the dipole moment value of this substance is 0. Okay, but on the other side, if you observe polar dielectric substance, so we see that here the center of mass of positive and negative charge don't coincide, right? So this is how we defined a polar dielectric substance and a non-polar dielectric substance. In case of non-polar dielectric substance, the center of mass of positive and negative charges coincide. In case of polar dielectric substance, the center of masses of positive and negative charges, they don't coincide, right? So that means individually they have a dipole moment. Individually, each molecule or atom, each molecule or atom is having a dipole moment value. Dipole moment value. That means each polar dielectric molecule will have a dipole moment. But when you observe the net dipole moment, or when you find when you want to find the net dipole moment value, then all the dipole moments of each molecule, they cancel out each other. As you can see very clearly that each molecules are randomly orientated, right? So the net dipole moment gets cancelled, and hence the dipole moment for not polar molecule also, it is also 0. All right. So net dipole moment is 0. Okay. So this is what you have to understand very clearly, that in case of non-polar dielectric substance, since the positive and negative charges, they are localized at the same position, you don't have any distance between them. So that is why the dipole moment is 0 for this entire dielectric, non-polar dielectric substances. But in case of polar dielectric substance, even though each molecule is having a dipole value, a dipole moment value, but when we try to find out the net dipole moment, considering all the dipoles, all the polar molecules, so it gets cancelled, and that is why our net dipole moment value is also 0 for polar dielectric substances. And remember, we are doing it in the absence of electric field there. So here we will see that how a non-polar substance, non-polar dielectric substance, it develops net dipole moment when it comes under the influence of an external electric field. Okay. So as you can see here, there are two figures. In this figure, the dipoles, all the positive and negative charges, they coincide at the same position, and we don't provide any electric field there. That is why E is 0, right? So that is why your dipole moment value for this substance is 0. Okay. But if you see in this second figure, this dielectric substance is under the influence of this electric field E naught, which is in this direction, and because of which all the positive charges will be displaced. That means you will have small displacement, and because of this small displacement experienced by the force given by this external electric field E naught, because of which we will see a certain distance between negative and positive charges. Okay, and because of which what will happen, that each molecule, each non-polar dielectric molecule will develop a dipole moment. And if I want to know the net dipole moment of this dielectric substance, we will just add all the dipole moment value of all the molecules inside the non-polar dielectric substance. And now in this case, the dipole moment value will not be 0. We will have a non-zero value there. That means now in this situation, this dielectric substance has developed a certain dipole moment value. Alright, because of small movement of negative and positive charges, the negative charge will move opposite to the electric field E naught, and positive charge will move along the direction of E naught, because of which we see a small distance between those charges, and it will develop a dipole moment. Alright, so remember this point, that when a dielectric substance is under the electrical field, a non-polar dielectric substance is under the electrical field, alright, so there is certain movement of charges, and because of those movement, it develops a dipole moment, and because of which now in this case, the dielectric substance will have a non-zero dipole moment. Alright. So in this case, we'll be discussing about polar dielectric molecules. And when this polar dielectric molecule, when it comes under the influence of an external electric field, it develops a dipole moment. Now in this, we are having three figures. So in this first figure, which we see, all the dielectric molecules, they are randomly orientated, and that is why the dipole moment value of all, considering all the molecules in this dielectric substance, they get cancelled. The dipole moment value gets cancelled, and because of which, when you don't provide him any electric field there, your dipole moment value is also 0. But when a certain electric field value, in this case E naught, when a certain electric field value is provided to polar dielectric substance, then what happens, that all the dielectric molecules, they orient along the direction of this electric field, external electric field E naught. Right? If you see figure number 2, there is a little orientation of individual molecules, dielectric molecules, but it is not totally along the direction of electric field E naught. Right? So if you want to have a dielectric molecule totally along the direction of E naught, what we do, we increase the value of E naught, external electric field, and when we increase the value of external electric field, we see that all the dielectric molecules, they are completely orientated, and now in this case, in the third figure, we see they are completely along the direction of the E naught value. Right? So now in this case, we will be having a certain dipole moment value, a non-zero dipole moment value. Alright. So similar to non-polar dielectric substance, here also we have seen that when a polar dielectric substance is under the external electric field E naught, a certain dipole moment is induced. Initially, it does not have any dipole moment value, net dipole moment value, but once it gets under the influence of E naught value, external electric field, so it develops a dipole moment value. Alright. So this phenomena is known as polarization of dielectric substance. So that means the development of dipole moment in the presence of external electric field. So that development of that inducing of dipole moment, so that is known as polarization of dielectric substance. Okay, so till now we have seen that how a polar and non-polar substance, dielectric substance, when it comes under the influence of electric field, how it develops a dipole moment, and this development of dipole moment, or you can say inducement of dipole moment, is known as polarization of dielectric substances. But this polarization of dielectric substances, it decreases the electric field inside the dielectric. Okay. So to understand this fact more clearly, you can see two different figures here. Okay. Let's just consider a dielectric substance is inserted between two metal plates. As you can see here, this is, let's say, it is plate A and plate B, and both these plates are given different charges. A is positively charged, B is negatively charged, and because of which you are having an external electric field E naught, and inside this region you have inserted a dielectric. It can be any dielectric, whether it is polar or polar dielectric or non-polar dielectric, it doesn't matter. So when this dielectric is inserted in this electric field region, so all the molecules, dielectric molecules, will be aligned along the direction of electric field E naught. Right? Now what will happen here, if you see all the positive charges, this first vertical column positive charges, these positive charges will be cancelled with the nearby vertical negative charges. Okay. Then again, here also you are having a vertical positive charges, vertical column positive charges. They also get cancelled with this vertical column negative charges. Right. So inside this dielectric, this cancellation of charges continues, and at the end you see certain uncancelled charges at the two opposite surfaces of dielectric. You see uncancelled negative charges at this surface, and you see an uncancelled positive charges at this surface. Because of this uncancelled charges induced at the two surfaces of a dielectric substance, you come across an electric field E suffix P. Okay. Now this electric field E suffix P is due to the polarization. Okay. So this is electric field inside the dielectric due to polarization. Okay, and this E suffix P, that means electric field due to polarization, this EP reduces the external electric field E naught. Okay, it reduces, that means it tends to reduce the E naught value, right? And since it tends to reduce this E naught value, you have a certain net electric field. Okay, where E is my net electric field inside the dielectric. Net electric field inside the dielectric. And this net electric field E is nothing but difference of E naught and EP. That means electric field due to polarization. So this much amount of electric field, and this electric field E is along the direction of E naught. So as you can see here, this is that electric field E which is along the direction of E naught. Alright. So that is why we say that when a dielectric substance is polarized, it actually reduces the electric field inside the dielectric. And because of which we come across another term known as dielectric constant. Dielectric constant. And this dielectric constant will be related to the dielectric substance which we have inserted between these two metal plates, right? And sometimes it is denoted by just like this, or sometimes it is denoted by like this. All right. So it is nothing but the ratio of the electric field in vacuum. That means when you don't insert this dielectric substance in between these metal plates to the electric field inside the dielectric. Alright, that is E. So it is nothing but E naught by E naught minus EP. Okay, so this is how we define a dielectric substance. So this property of dielectric substance, when it comes under the influence of electric field, this property it is implemented very much in capacitors. Okay, which actually gives us a more greater value, a capacitance value. We will come across all those things in our later class. Okay then, thank you.